If we understand how those atoms are arranged, then we can understand how to make these materials better, and how to make them more efficiently, and how to make them perform better. We're talking about materials that can be used for infrastructural applications like complex multi-phase steels, all the way down to the structures you'd find in your smartphone. We are at NIST, which is the National Institute of Standards and Technology in Boulder, Colorado. So the technique we invented here is called transmission electron backscatter diffraction. We start with a very thin sample that's about 100 nanometers thick, and we place that thin sample into the electron microscope chamber, and then the electron beam is going to pass straight through that sample, and as those electrons interact with the atoms in the sample, they're going to start to scatter, and that's how we can actually measure what and where those atoms are.
I had this brilliant epiphany. Well, these are TEM type samples. I wonder what would happen if we put them in a TEM mode in the SEM. So we put them in a TEM mode, and lo and behold, we could get diffraction with the transmitted mode, and that was really the birth of transmitted EBSD. There's probably 10 SEMs for every TEM in the world, at least. And so it gets the technique into many more research people's hands.
The reason that this advance is so important is we've improved the spatial resolution, and by about an order of magnitude, or a factor of 10. We're now able to look at structures that are indeed small enough to look at state-of-the-art, or what will be state-of-the-art types of components in all these different types of materials.
So it's become a go-to technique for anybody that has transparent samples or TEM type samples and can do it in the SEM. Well, this makes a difference. To actually be on the forefront of doing that, that's sort of interesting. You sort of dream about those things, and this came to fruition. You say, wow, that's cool.
It's a big deal. You want to do work that matters. I think everybody wants to do that. But at NIST, we have a very specific mission where we have to directly touch companies or industry sectors in order to matter. We need to be able to demonstrate that there's economic and commercial impact. And this was one of those cases where you can actually matter a lot.